Welcome everyone, and good morning. I'm Az, and I'm software engineer at Microsoft. I am also co-organizer of Girls Geek Sydney and She Hacks.
And I'm David Burela. I'm a software engineer at Microsoft. Today, what we want to do is take you through the journey of Microsoft AI services. What we want to do today is show you that we've got a lot of AI services which are really, really easy to get started with. And we want to show you a bunch of examples on how you can go and use these. Now, all of these ones that we're showing today are for people like myself who are not machine learning experts or data scientists. I don't know much in the space, as is the expert. So what we want to show is all the things that you can start using today, not understanding how they work. And so the agenda for today is we're going to kick off by looking at the continuum of AI services we have at Microsoft to give you an idea of the landscape of what is available inside of Microsoft. But we're going to go and dive down into a specific subset of them called the Azure Cognitive Services. These are the ones that you can just start consuming. And then the bulk of the presentation is going to be those three big demos at the end, where we're going to show you how you can actually start using these and how you would go about embedding these inside of applications. So to kick off, the Microsoft AI platform, we kind of chunk up into these three bits. We've got infrastructure, services, and tools. So looking at the infrastructure, those are all the very raw, low-level bits if you're going to go and train up and build your own machine learning models. We've got the places for you to store your data, so the traditional places like Cosmos DB, Azure SQL Database, Data Warehouse, Data Lake, all the places you're going to have and store your data because you're going to need massive amounts of data if you want to train up your own machine learning models. If you were building your own, you need to have some compute so you can go and run those models. So you can do them inside of Apache Spark, Azure Kubernetes services, running them on the edge, batch AI. And we also have these special data science VMs where it's a special virtual machine image where we've pre-installed Jupyter, R, Python, etc., etc. So those are good ways to kickstart yourself if you want to build up your own machine learning model. But again, for people like me, I don't know how to do that. So I would use the services. And these services are pre-packaged ones that Microsoft have built that you can just start consuming today. We've got the conversational AI, and the conversational AI is all around building chatbots. Chatbots that you can use inside of Skype, Slack, Teams, etc. We've got the pre-trained services, which are the cognitive services, which again is where we're going to be focusing on today. And we've got ones such as Azure Machine Learning, which can just help you build your own machine learning models if you want to, but without having to get as low level. And then tying it all together, we've got the tools. So the traditional Microsoft Visual Studio tools, we've got the tools for AI, Azure ML Studio, etc. And we support all of the different third-party libraries. So again, the ones we're going to be focusing on today are one subset of these, which are the Microsoft Cognitive Services. The idea behind these is trying to think how a human would look and perceive the world, and they would do this through vision, speech, language, knowledge, search, I guess. But we're taking the analogy a bit too far there, but the same ways that a human would. So the two that we're going to really be diving down into today is a subset of this subset, which are the vision and the language ones. Now, as a quick overview of each of these, the vision ones are helping the computers take in photos and video streams and try to figure out what's going on inside of them. We've got ones as computer vision, which we will demonstrate later, which allow you to give it a photo and it will tell you what's inside of that image. One's for face, for detecting humans, how many humans are there, what are their age, genders, their emotions, bringing that out through photos and video feeds. Language is all about taking written text and trying to extract meaning and information out of them. We've got text analytics for detecting the sentiment of that text. That piece of text, is it are people expressing anger? Are they happy? What are the key words inside of this phrase? We've got text translation, and we've got ones around spell check to help picks up that text. We've also got another service called the Language Understanding Service. Now this one is great for chatbots. This is all around a chatbot being able to take in that text and trying to infer what the user is trying to do. Are they trying to set up a new account? Are they trying to query and get back a piece of information? So those are the two that we're going to be focusing on today. But to give you a brief overview of what's available, the speech services are all around taking in an audio stream and trying to do something. So it's either audio to text or text back to audio. There's multiple cool things in there. We've got like speech to text, of course, which then you can go and feed back into the language services we just saw before. We've got speaker recognition, which is great for if you're in a conference room, you've got 5 people talking, the machine's able to figure out which text stream is coming from each of those 5 speakers. And we've got speech to text, text to speech. Knowledge is all around helping a machine be able to query and give back results. Q&A Maker is great for chatbots again. So Q&A Maker allows you to create question and answer pairs, just like a knowledge base. So then a user can query a chatbot and get back answers. Hey, how do I access the expenses app? Boom. Q&A Maker will return back the result. And the final ones are around search, where we're using machine learning to help improve search around image search, doing visual searches, auto-suggest, etc. So these ones are more for enhancing applications, but the other ones were more for helping a computer understand meaning from the real world. Now, if you want to dive into some of these, there are some other talks you can see at the conference this week. For more around chatbots, we've got Vishesh, which is speaking tomorrow, and he's talking more about the Microsoft conversational AI stack. So if you want to know more about chatbots and how to build them, see that talk tomorrow. And if you want to know more about doing more of that natural language thing with speech, on Friday we have Vish and Madoka from Japan presenting on Friday. So that's another one you may want to see.
So in Microsoft, some of these cognitive services we are using actually in our products. So if you see this photo, if you want to explain it, what do you explain it? So like, I would say it's a family photo, but let's see that what computer vision says. And then we know that it's important to have alt text for all of the images in your websites. So sometimes we are less creative on explaining the images, so we can use cognitive services to explain what actually is inside the image. So if I go back to this slide, so this is generated by computer, and it says, a group of people posing for a picture with a dog. Seriously, I couldn't explain it any better. And for this one, it says, a close-up of the kangaroo sitting next to the body of water. So to make sure that it's not something that I generated, it automatically generates. So as soon as you copy the photo, it automatically generates the text. It calls the cognitive services, and it returns back the vision. To show it quickly, so in Microsoft, we are embracing AI and machine learning, and we try to make sure that you can call and use these services anywhere in any of our products. So in the Excel, you can use custom models, or the reason that we are going to show you, because the Azure Machine Learning add-ons in Excel, by default, it has the sentiment analysis. So if I can get to my Excel file. So for example, you have a review of your apps, and you want to get the sentiments, all of the comments that people put. So you don't want to go read all of them together. So you just want to see that so in general, are people are happy or not? If you want to review a TV shows, comments, they want to see that if you want to invest and advertise in the TV shows and promote your products in the TV show, is it something that people like or not? So you can have all of your tweet or all of the text here, and Azure Machine Learning, it's the add-ons that I added. It's in insert, so I can get an add-ins, and it's in a data analytics, Azure Machine Learning. I already added here, so by default it has a text and sentiment analysis here. So all I need to do is selecting the rows and then say that where to show the output. And when I click on predict, it shows that if they are positive or negative straight away. And then you can show nice pictures, graph charts to show that in general, is it a positive message or is it a negative message? Back to you, David.
So those two quick demos were just to very quickly demonstrate how we could go and embed these type of services inside of consumer apps, so normal people can start using these without knowing what's actually happening. The Excel one is a great example of how you could give it to, say, your parents who've got an Instagram account. They could go copy and paste all of those comments into Excel and get back, hey, what's the general sentiment of these photos? What we're going to do now is dive more into some of the advanced services and how we'd go about using these inside of Visual Studio or other services. So if we're going to do that, we're going to need to start spinning some stuff up in Azure. Now, there are two main ways you can do this. You can either go up into the Azure portal, and inside the Azure portal, you can go create cognitive services and select which of the services you want to use. Now, most of these AI services all have a free tier. So you can use those free tiers while you're experimenting, and it's not going to cost you anything while you're just trying to get the stuff going. Now, you can create them inside of the Azure portal, but inside of Visual Studio, there's also an extension called the AI tools. And if you have them installed, now inside of Visual Studio, you can right-click your subscription, click Create New Cognitive Service, and you can say what type of thing do you want to do. Do you want to do around text analytics, face recognition, etc. But we've already pre-created them. So once you have a bunch of these inside of your subscription, so we can see here inside of Az, we've got Bing Search, Bing Spell Check, Face API, etc. So we've got them inside of her subscription, but if we want to get started, question?
Just a quick question. So how do you get all those options inside your Visual Studio?
This.
Install something like in Excel, install an API?
Yeah. So the question was, how do you get that add-in? So if you go to extensions and updates, you go online and just search for AI tools. It's not there. It's somewhere. But I installed it last night, and that's where I got it from.
So
It might not be popping up because I've got it installed.
yeah. So you can search it AI Tools Visual Studio plugin, and it already will show the results, and you can install it.
And then it appears up here inside of the menu. Now, if you want to get started with these, a few ways you can go about it. The traditional way is to go up to docs.microsoft.com, look up these services, find some code samples, copy, paste, etc. But we've made it even easier than that. So if we want to get started with a spell check, we can right-click, create a new application. Actually, I'll show you a different way first. We can go File, New Project. And because I've got the AI Tools extension installed, it's AI Tools. Thanks. We've got a whole bunch of templates here, cognitive services. So you can go and click one of those, hit OK, and we've got some templates there that you can get started with. But you still need to copy and paste in your subscription keys and things like that. So we've gone one step further to make it easy. If you right-click on one of those services inside of your subscription, you can actually click Create New Application. So doing it off the Bing Spell Check, I'll put it inside of this PC, C drive, demo NDC, and we'll call it the Spell Check Demo. And what that will do is it will create a template for you, but with all of the API endpoint URLs, the subscription keys, all of that. So it's a much nicer way to get started. You just run it and hit F5. We click Run. So what this has created is a little console application which is already hooked into all of... Let's just rebuild. I might have been a bit too hasty. There we go. I think everything was still just loading up, so the NuGet packages hadn't restored before I run it. So what it's creating is, I'm just going to crank up that font size. Too big.
28.
Go 28. There we go. Console app that we can test this with. So if I type in something like blockchain is awesome, where I've spelled it wrong, it will pass it off and the spell check service will come back and say, no, what you really meant is blockchain is awesome. Yes, a little simple demo, but the idea there is to show you how you can automatically get started with these. Another one we've got is sentiment analysis. There it is, text analytics. Right click, create a new application.
Or you can select it, add it to the same solution.
It's fine, I'll create a new one otherwise. This PC, C drive. Okay. The idea of this one, text analytics, is taking in that piece of text and then trying to extract out some analytical information out of it. So which language is a piece of text from? What are some of the key phrases in there? Are they happy, sad, etc.? So if we hit run on this one, build succeeded. Okay, so what's happening here, if we go and look back at the C# code, we're putting in 3 different pieces of information. One that's written in English, one in Spanish, and one in Mandarin. We come back, it says English, Spanish, and Mandarin. Useful for figuring out what text it is. So if you've got a comments box or you've got feedback coming in from your hotel reviews, you can figure out which language is it in. Next one, we've got a bunch of different phrases where we've got it in Japanese, German, English, and Spanish, saying different things, but we're going to extract out what the keywords in them are. So for the one in Japanese, I don't know. For the one in German, it's pulled out that hotel and that are important. For the English one, my cat is as stiff as a rock, cat, rock. And the last one is around, I had the best day of my life, this was a waste of time, and we're pulling back the sentiment analysis scores. So again, taking in feedback from customers, etc.
Is there any way to influence the algorithm that does all this job? Can we have our customized?
So the question was, is there a way to customize the text analytics?
Yeah.
No. So the point of these ones are that they are pre-packaged ones that you can just use, as is about to show ways, other models that you can pull down.
Yes, the samples are on GitHub.
Actually, is there anything that works mostly with VS Code?
Yeah, so all of the AI tools, there is extension, exactly the same extension for VS Code. Yeah, so you can download AI tools for Visual Studio or VS Code. Right. So we now saw that computer vision can explain what you see in the photo, but does it actually show that it doesn't? We want to see that if it's possible to see how many people are in a photo. Are they smiling? Are they wearing costumes? Are they wearing makeups? So there is another API that you can call, and it's called Face API. So what I really like about Microsoft Cognitive Services is when you go to the website, too soon? So when you go to the website, you can select which cognitive services you want to try on, and then there is an API reference here that you can see all of the references in the for the cognitive services, and you can try it here. So I can say that if I want to try it on Australia East, it automatically take me to the dashboard that I don't need to use any third-party tool to try the API. I can literally try it on the website. So here I can say that what I want from the API. So I want to say returns back the face ID if there is a, so I don't want to know that the position of the eyes or lips because I don't want to build the augmented reality. I don't want to use it in augmented reality things. And then the face attribute, so I can go here and I can say I want to have gender and emotion. So you can see here in attributes. For some reason I'm blind. Yeah, so age, gender, smile, glasses, makeup, and so you can see that if the, so you can get any information that you want, and you need to provide your key. I already created my resource here, and I can copy the key and put it back here. And then it asks for the URL of the image. I have it here. And if I hit send, yep, so it returns back the JSON result. It says that my mom is really happy, my dad is happy as well, and did it add the gender? It's there? Yeah, okay. Where is it? Ah, yeah. Yeah, so you can see that it returns back all of the information that you want. Now, if you want to say that if I want to, it's very cool, but what if I want to run it on the edge, so on a device? So for example, I want to build a silly app that it detects the emotion, and it's a competition that who smiles or who laughs more, it's a winner. It's like a next Flappy Bird. It's a very cool idea. Or you want to build a wrinkle detection. So it's kind of like, you know, when you go to the zone, you just start concentrating and you just wrinkling. So you want to see that if the emotion, so, but if I was happy, it doesn't detect the wrinkles, so there's no wrinkles. So you can say that I want to build an app that it automatically detects that, and it sends me a notification, smile, you know, so, or maybe time for break. So you can use Windows ML that you run the models on any Windows devices. So you can use this, you can use the pre-built models in C#, C++, or JavaScript, and Windows ML, it evaluates your model and it runs it in a best performant way. So it automatically detects that it doesn't need to run it on CPU, or it doesn't need to use GPU or DirectX. So it's a preview, and I'm going to show the sneak peek of how Windows ML works. Windows ML used the Onyx model. Onyx model is open format for machine learning models. The good thing about Onyx model is you can train your model in any framework with any tools and convert it to Onyx and use it in other frameworks. So it's a community project that started with Microsoft and Facebook. Now there are so many companies that are adapting this framework because they found it's very cool that you can get benefits of every framework without locking it to a specific framework. So to download the models, there are so many machine learning models that you can use, so you don't need to train your models from the scratch. So Azure gallery.azure.ai, it has all of the models that you can download. So if you go through the models, you can see lots of pre-built models that, and then it shows that they are in an Onyx format, and then you can use it in the Windows ML. I'm going to use the emotion recognition, similar to the API, but this one, I can use it on the device without calling the API all the time. So you can have it wherever that there is not possible to call the API through the internet, or because of the cost, and then you don't need that much detail, so you can run it on the device. I have already downloaded it, but to show you how it goes. So you can hit download, and it explains it what's the input layer. So it's looking for 64 by 64 grayscale image, so the channel is 1, and the output is array of 8 values, and it's exactly the same as our API. So it says that if it's neutral or happiness or surprise or sadness, so it returns back the array with the prediction against each emotion. So I have already have a pre-built UWP application. It's nothing in there. So what I do have, I have a it opens the camera. So it has permission for the camera, and so it's a blank image. So we are going to use the model together to build the emotion detection app together. So the only thing that I did to give you the if I go to the new get packages, yeah, thank you. So the only package that I installed is Microsoft Toolkit UWP, so I can get the camera preview. And here I have my toolkit here with the camera preview there. And I set in my manifest to allow to use webcam. So that's pretty much it to build the bare bone of the app. Now, if I use the downloaded model, that's the magic part. And I only need to drag and drop. Well, it's not. So I only need to drag and drop it on a project, and look what happens. It automatically creates a C# file for me, and with all of the information for the input layer and output layer. And all I need to do here, I need to define my model. So I define my model, and I define the array of the emotion, which we saw that in a website. And then I need to call the model, that instantiate the model. So first I load the model. It's in an emotion recognition annex here. The only thing that I need to do in this version, which in the newer version you don't need to do it, is in the properties. You need to make sure that it's content. And copy always. So it loads the file, it creates the model for me, and now I have my camera, the camera gets the frame. So now I need to load the frame, send it to the model, and get the result back. Basically, I get the video frame. The model automatically resizes the frame for me to 64 by 64 and make it grayscale, so I don't need to worry about this conversion. And then I call the evaluate async, and I put the input model to the model, and I get the result back. And hopefully, fingers crossed, if everything works, now we should have an emotion detector app. Building. Yeah. So this system doesn't have GPU, so it's slightly slower than the GPU versions, but still I would say it's in a very performant way. Build succeed, okay. This is the hardest part, smiling for the camera. All right. All right. My God, I'm not sad. Right. So, but you can see the counter here. So it's very instant. So there is low latency. And if you try it on a GPU model, it's quicker. So you can see that it runs the model in the milliseconds. It's very flawless. I want to make it. Let me surprise. Yeah, I'm happy. So I was worried that it shows fear because the public is speaking, but I'm not sad. But you see that how cool it is. So you can develop it in. So for example, you can run this model on an IoT device, and then you can in a customer service, and say you just respond. So if you see that someone is angry or frustrated, you can send someone to service them instead of asking them to wait in the queue. So you can improve the customer service by just detecting emotions. Or you can build an app for the kids to work with their on their emotions. So there are so many kids that they might not be good with detecting the emotions. So you can teach them to detect the emotion by these apps. So you can use this idea, this very simple idea, in very different this concept in very different ideas and apps. Yeah, over to you, David. No? No, it's the next one. Yeah. Sorry, good.
So as just showed how up on the Azure Gallery, there's a whole bunch of pre-built Onyx models that you can take down and start using inside your own applications to bootstrap your own machine learning and enhanced applications. This next demonstration that we want to do is showing how you can go and build your own Onyx models. And the way that we're going to do this is with a service called the Custom Vision service. The idea behind the Custom Vision service is you've got some images that you want to classify. Is it one of these or one of those? So in this scenario, we're going to pretend that we've got an autonomous car, and we want this car to be able to detect stop signs. So we want it to be able to classify, is this a stop sign or a give way sign? Because we should be doing something different for one or the other. And sorry, was that a question down the front?
Yeah, actually, before we get to this one,
Yeah.
the previous one, is there anything available for mobile?
Is anything, so the question was, is anything available for mobile to run these type of models on it? Yes, so do you want to speak to that, iOS and Android?
Yeah, so it depends of the solution. So we go any further, but you can use the TensorFlow or Core ML models. So if it's a question.
Yeah, and so inside of the iOS, Android, Xamarin, there are multiple ways to run these type of models inside of those ones. And unlike iOS, they can accelerate them. I'll show a slide later which says another talk you should go to. So we're going to be using the Custom Vision service. So this is at a really cool URL. It's at customvision.ai. I like that URL. So if you go and log into there, you can start using the free tier. Let's go back up one. Click that icon. There we go. So when you log in, there are free tiers that you can use to start playing around with them. And I think it's limited to 100 images or something like that. But it's to build your own custom Onyx model to do an image classification between multiple different images. It's as easy as going into this portal, clicking Create New Project, and then just clicking and dragging in images and clicking a checkbox for what tags they are. So we've got one that we've pre-built some, like, is this a hot dog or a sausage dog? But the one we want to show off is it a snowman or a sandman? So for this one, all you have to do is click Add Images. I could go and add another image, such as this one. It'll say it's going to add it. What tags do you want to add for this? So that's another snowman. Upload. Once you've gone and uploaded all of your images, so we can see we've got multiple ones there for snowman, a couple of sandman. Well, they're on the beach. Now, once you've done it, you click Train, and that's literally it. You click, drag up your images, tag them, hit Train, and it will go and use all the Azure CPUs, go and train it up, and then you can use it. So it should only take a couple of seconds. There we go. And it's gone and shown back the results for it. If we want to do a quick test on that, we can hit Browse. I can hit that one, and it'll come back and tell you that it's probably one on the beach. Yay. Very easy. Now, that's great, but what we found was to do these, there's a bit of a bootstrapping problem. You need to go and source a whole bunch of sample images to help train this up. The minimum amount of photos that you need is 5, but you're not going to get that great results out of this. The more images you can throw at this, the better. And so what Az built was a cool little console application that can help you to bootstrap these projects. We go into Visual Studio. All you have to do is, this is available on GitHub. You pull this down, you add in your access keys for custom vision, paste it into here. You go into the CSV file and put in what you want it to go and bootstrap for you, and that's it. You hit run, it'll go and use, I'll hit run. What it will do, it'll go and use the Bing image service that we were showing on the slides before. It's going to go up, search for those images, pull them down, create a new custom vision project for us, upload all of them, pre-tag them. So it's a really great way to bootstrap your projects. Now, you don't use this as a starting point. You still want to train it up and refine it with a lot further, but it's a good way to very quickly get started. So it's pulling down a whole bunch of images at the moment. There we go. We're now uploading them all to our custom vision service. It's tagging them with the correct tags. Is it a giveaway sign or a stop sign? It's invoked it to start training. We'll give it a few seconds. And then after it's finished training, it will go through and it downloaded more images that it needed. So it can go and the extra images that it's got, go and run them against that trained up model to try and return back how good was the one that was done. So let's see, from our sample ones, it correctly identified 3 out of 3 for giveaway signs and 3 out of 3 for stop signs. So it looks like our model is okay. Let's go and check it out. If we go back up into the portal, we should see a new one here. Here we go. So these are the images that are pulled down from the Bing image search for us. A couple of stop signs, a couple of giveaway signs. So if we click Quick Test, we've got some more images that we've prepared. Traffic signs. First one? Let's go to the first one. Bam. And straight away we're getting 96% accuracy for detecting these stop signs. So again, it's just a good way to bootstrap yourself.
So now the question is, can you run it on Edge? Can you run it without calling the API? And the answer is yes. So you can export it as a Docker image, and then you can run it on any device. So you can run it on cloud, on PERM servers. You can run it on IoT devices that they support Docker, or you can deploy it to the Azure Container Service and then deploy it to Spark clusters. So there are different ways of using Dockers. And let me show you quickly how you can do it in 3 clicks. So the first thing that you need to do is you go into the settings and you just need to get the compact version. You select the compact version and you retrain the model with the compact version. So when I saved it and I train it again, it takes probably 1 minute or 2. Yeah, it's already there. So. And as soon as it shows the export button, so the export button, you can export it in CoreML, iOS, TensorFlow version to use it in Android apps, or Onyx model to use it in WinML that we showed it previously, or you can get it as a Docker file. And you can set up what type of the containers you want. You want a Linux one or Windows one. I go with Linux. So it's getting it ready for us based on the settings. And I'm downloading it. So for those that they might not be very familiar with the Docker and containers, don't worry about it. There is a README file, and then you can all follow the steps here. So if I go command line, so the first thing is building your, so I have to go to the folder, sorry. So you can type docker build. Actually, I copy and paste it. It's better. Quicker. And then I name it as demo1 NDC. And it builds the image. It pulls down the Linux images and it tries to build it. And now I can run. Should be very quick, but if it takes long, I already have another one, so we can show the other one. Should we show another one? It's finished. Okay. So if I say docker image list, so you can see it creates the one 6 seconds ago, demo1 NDC. Now I can run it, so I can run docker run, and then HP. In a detached mode. I don't trust my typing. Yep. And then, so you can see here it says the image name, and I named it demo1 NDC. No reason from the demo drive refer external connectivity to endpoint. Yeah, so let's try a different port. 81, 82. All right, demo got us. Anyway, so you can run it. It used to work. And then you can run it, and then you can use Postman to hit the endpoint. Super easy. It always work, but give up. Right.
So if you want to learn more about running your models on the edge, you want to see demos that work, you can go along to this other talk, which is on tomorrow. Being done by David Glover and Nigel, who's sitting at the front. Now, Nigel is my boss's boss, so please go along and tell him how much you loved our talk. We'd really like it. Okay, now we saw how we could go and train up a custom vision model to go and do a classification around giveaway signs and stop signs. And that's one type of problem around classification. If we want to amp this up to the next level of difficulty, now we've got parking signs. Parking signs aren't just binary, is it give way or stop sign, yes, no. They have a lot of detailed, dense information inside of here. We've got how long are we allowed to park here, the time of day that you're allowed to park there, and which way is it? Is it to the left, to the right, is it everywhere? This makes it very difficult. We've got text, but we've got unstructured text. It's in different places and many different signs. We've got a very difficult problem here. And so what we want to show is, we've shown many different ways of building up applications so far, either doing it from the website inside of Excel, using inside Visual Studio, and Az is going to show a totally different way that we can go about building one of these up.
Thanks, David. So for building this application, I used I used Python and said, okay, let's do it in an exploratory way. So I used Anaconda. So the cool thing about Anaconda is you can have a different virtual environments. So you can have so if you're using different version of Python or different version of TensorFlow, so you can set it up and so you can set the environment as you want. So I'm using. And then I'm using Jupyter Notebook to run my Python code, and then I can see the results straight away, block by block. I found it very interesting. So the first thing that I did, I just show you a quick config. I'm not going through it. So I updated my PEEP version. I installed a module called Azure Cognitive Services Custom Vision, and I installed Flask. Flask is creating web API in Python. And let's go through the explanatory notebook. So similar to do we have any Python developer here? All right, cool. So do we have C# developer here? All right. So for the C# developers, it's exactly importing the libraries that you do it. You know that the using the libraries. So here in Python, it's called import. It's exactly the same. And I have a bunch of functions that I explain it one by one. Now let's say about the problem. So the problem is we have an image, and we wanna detect. So this is my image. So I can run the block. Okay. So this is my image, and what I want to see in this image, I want to detect the area that I can park, and I want to return the boxes. But the first problem is reading the characters. So let's start from the scratch. So first we want to see the characters that we want to see. So I used the OCR. So in OCR, it detects all of the characters in the image. But as you can see, it misses some of them. So there is another service called Recognize Text. It's developed initially for reading recognizing the handwritten text, but in our scenario, it's more performant. So when I use it with the printed tag to detect printed text, it works better for me. So I use the Recognize Text. So as you can see, it picked all of the characters, so I didn't miss anything. Then we get to the find sign. So in the find sign, what we like is detecting all of the bounding boxes for the areas that we want to use and combine and showing the text that in the bounding boxes. I use custom vision object detection. So this problem in computer vision calls object detection. So you want to detect a specific object inside the image. So in an image detection, in an object detection, I uploaded a bunch of images, car park images. And I tagged them. So for example, here, you can see this is my sample image. I tagged this image as a parking sign, and I tagged it if it's an arrow pointing to the right. And I provided different samples. So using with this tool is super easy. You upload the image as David showed you, and then you can put the bounding boxes and tag them, or you can use any other labeling tool that you are familiar with. Like you can use VGG or any other tool, and then you can use the custom vision object detection APIs to upload the images and upload the tags. So it works perfectly. So you don't need to always use this tool. So after that, I train the model, and I have the API. So if I go back to show you the code, this is my find sign, and I call the prediction API. I send the image, and it returns back the probability of each object. And then I said that use the recognized text and pick the text in the area that we pick the bounding boxes. So that's why, yeah. So it returns back the bounding boxes with the text inside the bounding boxes. So if there is the other signs here, so we don't detect them. But at the end, for the productionizing of this idea, we need a service that gets the image, returns back the JSON object. Inside each JSON, inside the JSON, you have the array of bounding boxes with the text in it, and the array pointing right to left. Yeah. So when the exploration part's finished and you're happy with the product, you can go through and build your service. I could use Flask in a Python object, but I found it's easier to show you how. So I have the. So now on port localhost port 900, if I call this endpoint, it should return back the JSON object for me. In the header, I just said that the content type is the octet stream, and in a body, I can select the image. Where is it? Yeah, cardboard. So I can select and hit send. Still running. So you see that it got the endpoint and it returns back the result. So you can see here it picks up the areas, so it returns back the array of sign. It points that if it's a left to right, and it picks up the text for each sign, text in each sign. Yeah, so that's pretty much it. So you can use it and you can Dockerize it. You can deploy this endpoint anywhere that you want and you can use it. So now we know about the concepts of image classification and object detection. So there is an app called iNaturalist that they are using these concepts in their products. So let's see how they use it.
iNaturalist is a social network where anyone can record and share their photographs of living things. When you share a photograph on iNaturalist, it becomes more than just a picture. It becomes an observation. It's a record of an organism in a place at a time. Each observation is shared with a global community of naturalists, where it can be identified, discussed, and used to give us a greater understanding of life on Earth. Wherever you are, biodiversity is there too. Get out and observe it.
So iNaturalist is a really cool, compelling app for trying to track the biodiversity across different areas. Now, iNaturalist is just one of the...
iNaturalist is a social network...
iNaturalist is something that's still playing in the background. iNaturalist is just one of the projects which Microsoft is funding under our AI for Earth program. So Microsoft, we're putting our money where our mouth is, where we keep saying we see that AI is going to massively impact everything in our lives around Earth, education, agriculture, etc. And so, as it says there, we're investing $50 million in this AI for Earth program. So far, we've given around 140 grants out to projects which are doing things which are helping the future of the Earth, climate change, agriculture, etc. So if any of you want to go and use the tools that we were showing today to go and build your own application to help the Earth, please go apply for one of these grants. Now, everything we talked about today, going all the way from the very simple services that you can just use as a consumer, through to the developer tools, the custom vision services that we showed, that really cool demo that Az showed at the end of how to tie in the custom vision with OCR, with bounding boxes, all of those, we've wrapped up those links up into GitHub. So if you want the link for it, I can see you're trying to take a photo of that one. We've got a URL for you to access all of it. So if you enjoyed all of that, please go and to that, pull down all of the resources, and on behalf of Azadeh and I, thank you very much for coming along today.
I was just curious, if you've built a model and you spent a long time training it and getting it right and it's quite accurate, is there a marketplace where you can then sell that model? Can you actually try and monetize it?
Not for selling it at the moment, but the Azure AI Gallery, you can upload your model there, and other scientists and developers, they can use it. So similar the one that I used and demoed, yeah.
Your AI tools for the Microsoft Excel.
Yeah.
How does the pricing model
How
work?
does the model work? The pricing. That one is for the demo, but it's there, so you can use it until they said you get the notification that you can't use it, basically. Yeah.
You can use it for commercial.
I don't know, to be honest with you, but it's there. So it's something. It's there, so you can use it. I didn't see any codes that you can't use it for commercials, but yeah, I can. Yeah, email me off one salesperson to talk to you about it.
What are the Visual Studio requirements for using these AI media packages or assets? Are they compatible with professional edition?
Yes. So the one that you saw, it's installed on Enterprise, but it works on a community version, on a free version as well.
For ONNX, you need a preview version of Windows. So the latest inside a preview has got the final. They've taken the preview off the API, and it's actually the final API footprint. So there's no breaking changes.
Does it work with .NET Core as well?
Yeah, for Windows ML, I don't know. I can check it for you.